Hello, welcome back to another of my new video. In today's video, I'll be showing you something interesting called kerosene or paraffin oil lamp. But before I move on to the actual oil lamp, I will be showing you the fuel kerosene itself or paraffin. It's known as kerosene oil or paraffin oil actually. In the UK you call it as paraffin oil. In the United States you call it as kerosene oil. It's basically referred at the same thing. But paraffin, the word itself can mean different things as well, including paraffin wax. With the crude paraffin oil, you can actually precipitate out paraffin wax from the paraffin oil, as well as the pharmaceutical paraffin oil, as well as other paraffin oil that is quite different to kerosene, that has a really high flash point with a really thick consistencies. But we'll be showing the properties of the oil itself shown here. The oil, kerosene or paraffin oil, has a low flash point, but it's not very low, unlike gasoline of negative 20 degrees Celsius or 30 degrees Celsius. Kerosene has the flash point of around 60 degrees, which is much lower than the diesel fuel. So therefore, sometimes some older generation diesel car, you can actually mix kerosene in it in the cold winter time to make sure your fuel doesn't freeze over from the tank. But most of the kerosene here will be shown is generally being taxed or untaxed, depending on whether you use it for. If you use it for automotive, it's generally taxed with the fuel tax, thus the fuel itself is not dyed. If you use it for anything else that is non-vehicle related, thus you don't have to pay any road tax, thus the oil itself does not have any tax involved, thus the oil has to be dyed with a specific fuel dye color. In some states the color is red, in some places like Europe the fuel color can be yellow with a special organic dye. The low flash point makes it useful since it can be easily ignited with a wick. It's also non-flammable actually. You cannot light it up on fire by itself unless you heat the oil up to above 60 degrees Celsius, which generates significant amounts of vapor in atmospheric pressure and oxygen conditions. But it's highly combustible. If it touches anything like wick or whatsoever, like carpet or whatsoever, it can easily ignite. So thus a spillage of kerosene on flammable surface is really dangerous. It has a really low retention time on cotton wick, so the kerosene oil itself actually behaves a lot like water, thus it's really thin, the oil itself. It can be also used on many different other applications, such as diamond grinding wheel. If you have a diamond plate sharpening system, if you use water, your plate itself will rust itself out really quickly, as water can damage the plating and coating metal substrate itself. But kerosene oil is not water. It does not generate any ions when being mixed with any metals, such as water can get ionized if got any salt within it, as water is really good to make ionic compound dissolve. So the low retention time allows the wick to draw the fuel itself high up with a really long distance easily, thus allows you to have a stable ignition. As well as the kerosene oil has a high carbon ratio to achieve yellow flame, unlike methanol, which contains oxygen as well, with a really low carbon ratio to hydrogen, thus the flame itself is really blue. Ethanol is also a really blue flame. Isopropane gives you a slightly more yellow one, but you can achieve quite a large yellow flame without sooting. But kerosene something is not. With more wick, it actually start to soot at a really low flame on a regular dead flame wick. Here is a candle, if you can see here. Candle actually will be given as the standard of the light intensity candelo, which is the old unit using a standard spermaceti candle with a standard wick. But here is something quite similar, but uses the paraffin wax that's actually precipitated from the paraffin oil during the distillation of crude oil. If we light the candle on fire, you can see here is quite a flame going on here. The flame actually is quite intense, also quite bright as well. As we can see here, if we enlarge it, close it, zoom to the flame. The flame first dies down, as the wick has not drawn any wax yet, But later, when the puddle of wax melts, actually the flame level will actually increase as the amber level on the wick will actually decrease. If we zoom it even closer, you can see now the amber on the wick actually disappears a bit. So actually what is burning mostly is not the wick. The wick does get consumed during combustion. But during combustion, actually, the wick carries the molten wax or the molten paraffin wax to the wick, and through the temperature hot flame, the flame generates a lot of heat. The heat itself vaporizes the paraffin wax from the wick, and the vapor of the wax burns. So you can see the wick consumes the wax, and the wick gets vaporized the wax, and the vapors of paraffin caught on fire thus produce the standard candle light. It's actually not really stable. If I put my hand around, might cop some wind down. But here we can see it's a standard paraffin candle. With this standardization, we can actually bring out our standard paraffin, really small little kerosene lamp. Here's the kerosene, you can see here, it's not too much inside. Kerosene has a consistency really similar to water actually, but it's extremely easily soak up through any fabric of cotton or polyester. So it's also really dangerous if you got anything spilt on your clothes, because you might not know and they can catch on fire, and the consequence can be disastrous. So here's something called the chimney. For a small wick lamp here, the chimney actually does the main thing is to draft the air up, thus stabilize the flame against mild wind. We can put up here. Here we can see it's a tiny little flame. It's followed the same exact wind direction of the wind blowing in this room. But if we cop this chimney down, you can see the flame gets much more stable. We need to zoom up to the flame much closely in order to see everything. So here you can see the chimney might be lightly dirty, but you see on my chimney, it's really different to a lot of videos shown of a dirty oil lamp chimney. The chimney of a actual oil lamp shouldn't get dirty at all from soot whatsoever, because from the proper usage of oil lamp, your chimney rarely gets any soot particles at all. So your wall shouldn't even get darkened at all, unless you do something of this using the wrong wick size. If you tune your wick too high, if I'm going to demonstrate here, you can see now the soot start forming. You can see paraffin oil can actually form in soot on a really low flame compared to the isopropyl alcohol, which can later demonstrate. This is due to the properties of paraffin oil containing a high number of carbon to the hydrogen ratio compared to the isopropyl alcohol. For ethanol or methanol, it's even lower of carbon ratio to the hydrogen and oxygen included, thus even lower the flame luminosity. The flame produces the light is due to the properties of incandescence of small carbon particles. The small carbon particles is actually what's creating the light here, you can see. You can actually, to tune the lamp, you can tune it just before it smokes and you should stop. At this point, it's the maximum luminosity of the light. Actually, you can see the paraffin candle actually produces a even larger amount of light and an even larger flame before the kerosene or the paraffin oil lamp start to soot. So therefore, with the same wick size, actually you would say that the candle can actually get brighter. But with the oil lamp design, you can actually use something called air dome to even maximize the flame combustion, which I will talk about in the next video. But here's it. Another advantage of oil lamp is that because you get the wick exactly at the same level, the wick actually never moves up and down, thus make it much safer compared to a candle, as the wick always remain on the same flame height level, thus make lighting also much more convenient as well. Whereas candle, it actually consumes itself. The level of candle actually goes down and down and down. And another really fun property of kerosene is that it smells horrible. The smell of normal combustion of kerosene actually produces a lot of bad smell. This is due to the impurities of aromatics and the sulfur-containing organic compound that causes the smell. Before I end the video, here is something called an alcohol lamp. Alcohol lamp work on really similar fashions to the kerosene lamp, as it uses a wick but burns alcohol. As you can see here, the alcohol is actually get capped. And with the instruction says never blow an alcohol lamp out, since you might actually blow air and flame go inside the bottle and cause it to explode. The consequence I would not say. Burning alcohol will pour everywhere. Kerosene oil, if it's spilled on the floor, I cannot ignite it unless I heat it a long time, but alcohol, no. Instantly ignites, which is really dangerous. But here I will show the comparisons of isopropyl alcohol combustion with a much larger wick, and it burns with a much bigger flame, thus not producing any soot. You can see here. The flame is not as intense, but it's a luminous yellow flame, not as intense as our alcohol lamp, our kerosene oil lamp, but with the same properties of shown here, because it contains oxygen inside the fuel itself. Thus, the flame does not produce much brighter light, as the combustion is already happening mixing in the fuel molecular level compared to with kerosene, which is pure hydrocarbons, nearly pure hydrocarbons. Thus, it does not contain any oxygen involved. That's it for this video. Hope you like it, as I shall see you in another of my new video.